Okay. Okay, so hi everyone. We're going to start the activity in a few minutes. Here with us is Ruth, all the way from United Kingdom. Okay. All right. Good afternoon, teachers, students, and everyone who is watching. The Engineer Student Council and the Academic Consulate team of 2020, thank you for coming to this event. We welcome Dr. Ruth Graham, who has worked as an independent higher education consultant since 2008. Her work focuses on fostering change in higher education across the world, helping to improve teaching and learning worldwide, and supporting the emergence of technology-driven entrepreneurship within universities. For the first part of the conference, Dr. Ruth will tell us about her experience in engineering education and her latest project about online teaching. Afterwards, we will have a round of questions that will last 20 minutes. You can ask your questions in English or in Spanish in the Zoom chat or in the YouTube stream. You can also raise your hands during the question round and open your microphone when I call your name. We ask you please that if you want to open your microphone to ask, the questions must be formulated in English. Welcome, Dr. Ruth. We are delighted to have you as our guest speaker. You may start your presentation now.
Thank you. It's a real pleasure to be speaking to you remotely. I've visited the university many times, and it's sad not to be there in person, but it's lovely to connect with you all virtually. What I'll be talking about, as was said, is looking at global approaches to engineering education and looking at the state of the art, but in particular how that is likely to change as a result of COVID. So I'll just click over to my presentation. So I hope you can all see that.
Yes, perfect.
Yeah, great. Fantastic. So I'm going to just talk about what's happening globally in engineering education, where institutions are and how it's been changing, because engineering education has changed hugely. Just to set a context, that engineering education over the last half century, in many ways, up until quite recently, hadn't changed very much at all. It was very much a traditional discipline, following a teacher-centered, what we call sort of sage on the stage teaching approach. So people, the teacher would stand at the front and talk to the students and impart information, and the students would listen. And in many ways, the curriculum really has remained largely unchanged at many universities across the world for 50 or 60 years, focusing very much on the engineering fundamentals and maths and science. And I studied engineering as an undergraduate, and I remember very clearly while I was an undergraduate in the 1990s, there was a Boeing. I wanted to be an aircraft engineer, and Boeing published a list of the desired capabilities that they wanted to see from their graduates that they were employing. So I kind of, as a student myself, looked at this and thought, this is really interesting. It's a huge breadth. So the first two are about the engineering fundamentals, a good understanding of engineering science, a good understanding of design and manufacturing. But actually the other 8 attributes that they were looking for at the time are not just about the students' knowledge, but it's about their skills and mindsets. It's about the greater capabilities of students, multidisciplinary perspectives, understanding of the context of engineering, communication, ethics, critical and creative thinking, flexibility, curiosity, understanding the importance of teamwork. And as a student, for me, these weren't things that I saw within the curriculum. And I worked as an academic in the mechanical engineering department at Imperial College. And again, there were pockets of some of these things, but the vast majority of the curriculum was very much focused on the engineering science. So I'd say I work as a consultant. I've done a lot of work with MIT, and there's been a lot of talk at MIT and many other universities worldwide, particularly over the last 10 years, about what is engineering education, who are we graduating, what are we looking for out of our students, and to what extent does the education that we provide develop those kind of capabilities. And MIT's actually made quite a big change. They've developed this new undergraduate program called the NEET program, the New Engineering Education Transformation, with a much greater focus on some of those other attributes, the mindsets, particularly, you know, what kind of ways of thinking, and that's the phrase that they use, the NEET ways of thinking for engineering students. And as they were making this change, they said they asked me to look at best practice worldwide, a sense of the engineering education is changing globally, and what could they learn and the global community learn from the best of what's happening. So I conducted a study commissioned by MIT looking at the global state of the art in engineering education. Came out a couple of years ago. I just wanted to highlight some of the key findings and some of the ways that engineering education worldwide is changing. So the four things I was just going to talk about firstly is the findings of this study, because one of the key questions that they wanted to know is which are the institutions worldwide that are seen by the community to be leaders in engineering education? Who should we be looking to when we want to make a change? And secondly, what distinguishes these kind of emerging leaders? What are the new generation of engineering programs look like? And what distinguishes them from the people who are seen to be the current leaders in engineering education? And then talking a little bit about the impact of COVID, because that has had and will have a profound impact on engineering education. So the first question, who are the current and emerging leaders in engineering education? I spoke to 50 thought leaders from 19 different countries across the world and asked them, who do you consider to be the current leaders? Which institutions are leading the world currently in engineering education? And secondly, who are the emerging leaders? Which are the universities that you think over the next decade are going to help to redefine what best practice looks like? So the 10 universities most often identified as the current leaders in engineering education, I think most of these are quite familiar to most people. Olin College, coming out at number one, is a very different kind of institution. It's small, it's a very hands-on education. It was only opened 15 years ago, but it's had a really profound impact. Others I think are more familiar, MIT, Stanford. Aalborg University is a problem-based university in Denmark. Delft, UCL, Purdue, NUS, Cambridge and Chalmers, I think are probably all slightly more familiar names. And then this list of who are the emerging leaders, and a very much more diverse group. I think it's interesting, given the audience, number 4 is Católica in Chile. These are institutions that the community is looking to with interest. For some of these, it isn't necessarily that they're at the cutting edge now, but they're thinking these are the institutions that are moving and are doing different and interesting things that we can learn from. So for some of these institutions, it's not necessarily where they are now, it's the trajectory and the speed of travel. But for others, they are incredibly interesting and innovative, and some institutions I had never heard of. So number 8 is Charles Sturt University, which is is a distance learning institution based in Australia. So with a very different kind of education. So I was interested to look at what distinguishes these emerging leaders that people are talking about. What's different between what they're doing and what the current leaders are doing? And there's some really interesting differences between the two groups. Firstly is the current leaders, and this was the first thing that struck me actually, was largely US and European based. Amongst the emerging leaders, there's a much greater global spread. So this feedback that I had when I spoke to the thought leaders as part of this study and asking them to identify which institutions they saw as current and emerging leaders, one thing was really interesting. So amongst the whole group of universities that they identified as current leaders, 54% were based in North America. So more than half were really the US institutions. Almost a third were European. When you looked at the recommendations people made for emerging leaders. I hope this is coming through clearly, but only half of the recommendations were in Europe and the US. A quarter were in Asia, and 11% were in South America. And there's a real sense of this is where some really interesting things are happening, and happening very quickly. That a lot of the traditional institutions in the US and Europe might be changing, but they're changing relatively slowly. And a lot of people were talking about looking particularly to South America and Asia for some rapid and interesting changes that were really going to change the landscape in the next 10 years. Another difference between the two was that the current leaders, there was pockets of innovation, whereas in the emerging leaders, a lot of these institutions are either completely new universities, new engineering schools, or completely new institutions, or they had systemically reformed the whole curriculum from start to finish, not just adding a few different kinds of courses, but completely redesigning the curriculum. So one example here is Olin College, I mentioned earlier. It's only been built, in the last 20 years. It's only had its first graduating cohort in the last 15. And this is a very, very different kind of education, really focused on developing students' mindsets in particular, there's a really strong focus on sustainability, on entrepreneurship, a very, very hands-on education that's really integrating their learning, and a lot of it is based around project-based learning. But Olin has been incredibly influential in terms of change at other institutions. Another big difference is that these emerging leaders are much less likely to be teacher-centered, they're much more likely to be student-centered, and a really palpable culture of student empowerment and cross-community collaboration, that actually a lot of the delivery and design has very, very strong student involvement. And there's a real shift there that feels very different, and you can feel it at many of those institutions as soon as you walk in the room, that these are very different types of education and a very different culture. So one example is this Charles Sturt University in Australia, really a completely new program. They haven't even graduated their first set of students yet. They're only 4 years old. And their education is very much project-based. Students come into campus to work on projects that kind of synthesize what they're learning, but everything else they learn online. So all of the topics that they learn, they've created this thing called the topic tree. So they disaggregate everything in the curriculum into 3-hour bite-sized pieces. And they've created this map that sort of offers a visual map of the connections between all the different things that students learn. And students access this independently. So they decide if they're doing a project and think, do you know what, I need to know more about strength of materials in order to tackle the project. They go to that part of the topic tree and master it. They just have to have completed a certain number of topics before graduation, but the student is very much in control of their own learning. And there are risks there. Students, if they don't engage, that they could fall behind and find that they've got a lot of topics to cover in the last 3 months before graduation. But they're able to identify, what do I need to know and understand in order to solve this project? And it's very much focused on students. There's a lot of work-based learning as well. So the students go out on work placements and again, keep accessing the topic tree when they identify something. Okay, so I need to know about fluid flow or whatever it is. They can access that and revisit parts of that and master different parts of the curriculum, but in a very independent way. Another big difference is the development, and amongst these emerging leaders, one thing that was very clear is the development of the new programs was shaped by regional needs and priorities, which enabled the university to take a much more visionary approach. Rather than saying we want to improve the education, that there was a really strong reason, very often linked to their particular region, as to why they made the change. And one example here is Católica, that actually a an element of the changes that's been made to the curriculum at the university has been driven through government investment in trying to develop a new cohort of entrepreneurial talent amongst engineers in Chile. And that focus allows, or appears to allow, a lot of these institutions to really be much more visionary rather than just generally improving the education. There's a really strong focus to why they're doing that. And finally, that among some, although not all, of the emerging leaders, there's gender parity. And again, this is something that you feel very, I feel as an engineer, a female engineering student myself, I was very aware of being in that 10%. But it's really interesting looking at this group of emerging leaders. Not all, I mean, I should say that some of them, that isn't the case, but a lot of them have 50% women, 50% men. And that appears to be linked to a very different student-centered approach to education. So those are some of the differences between these kind of new, this new generation of engineering programs that are emerging. And I just want to talk a little bit about what kind of things are they actually doing in the curriculum. And there are really 6 core aspects of these new programs that really stand out. The education is very multidisciplinary, that students aren't sitting in their silos of electrical engineering and mechanical engineering. They're really working across engineering, but actually across the full the full comprehensive disciplines, working with people from outside engineering. There's a very strong focus on global outlooks and experiences, a very strong focus on creativity, innovation, and entrepreneurship and problem solving. And linked to that, the hands-on experiential learning, real-world problem solving. So applying knowledge, not just learning things in abstract, in siloed courses, but actually pulling that together and having experiences, working outside the institution to apply that knowledge in a way that will allow it not just the knowledge to stick, but also to really understand how to apply these principles in practice. A very strong focus on the role, responsibilities and ethics of engineers in society, and sustainability in particular, it appears to be a really strong theme. And finally, student choice and flexibility, this sense of not just the personalized learning, but the sense that each student has a different pathway, different interests, different strengths, and the flexibility to allow each student to focus on their interests and strength, and allow those to change as they move through their degree. And these are all things actually that are part now of this new NEET program, which has grown hugely at MIT. Each of these aspects is a particular focus. Just to give you a couple of examples of what that looks like in practice. So one of the universities identified as an emerging leader is University College London, UCL in the UK. And about 7 or 8 years ago, they completely reformed their curriculum, and they developed much more multidisciplinary learning. So looking at these lists, there's this kind of 6 attributes. I would say that 4 of those they're particularly strong on. So the first 2 years of the curriculum, they have it in 5-week cycles. The first 4 weeks, they learn the theory. And then in the final week, they have an immersive project where they apply what they've learned in a real engineering problem. There's a lot of bringing students together from across different disciplines and across different year groups to apply their knowledge, and working with external sponsors and collaborators. Oh, sorry. So that, I mean, they've obviously still got a lot of rigor in the fundamentals, but this common structure is very different. And they've got, say, they've got this big project where they come together, which actually in some ways is probably engineering challenges and the research, innovation and entrepreneurship course, kind of a combination of the two. But they have a two-week intensive project where they bring students together with a lot of development agencies from across the world to develop solutions to various real-world problems. A second example is SUTD in Singapore. So it's the Singapore University of Technology and Design. New university. It was set up actually in collaboration with MIT. So it's got a very strong focus on the engineering fundamentals, but also very much focused on design, user-centered design. And actually, they cover all of these 6 elements. So there's a lot of hands-on learning, and a lot of cohort working as a cohort. All students live on campus and have access to fab labs, prototyping labs, and there's a really strong student-centered focus. So a lot of the activities are led by the students themselves. And they have quite a wide breadth in terms of the education, in terms of what they're able to do. So even though it's essentially an engineering university, they do a lot of courses on literature and all sorts of things. So it really has a liberal arts feel to it, which in some ways is inspired by what MIT offers. They also have this, what they call a 3D design approach. So so there's design projects and elements in everything. So within single courses, there's a lot of apply this to a design and work through it. The 2D part of it is saying, okay, we're going to bring all the courses you're learning in this semester, and you're going to apply all of them to a design project that you all work on intensively together. The 3D part is where they say, okay, so you learned this and developed a project in year 1. We're going to bring you back to that. Now you've learned a little bit more and you're going to develop it. And actually showing students how their knowledge and skills are changing over time and applying to the same problem and revisiting that. And then the 4D part is this student-led extracurricular activities, which were just phenomenal. That's a new university, and I think within it's a very small university, within I think a year or 2 of being established, I think they had as many student clubs and student-led activities as the National University of Singapore in total. So there's a really strong focus on this kind of student-led extracurricular activities. So I just wanted to finish with what's been the impact of COVID-19, because one of the things that came through very strongly from the study with MIT is at the core of so many of these courses is hands-on learning. It's the application of real, authentic problems, getting students in teams, working outside their discipline with different people, and building prototypes and working collaboratively with others. And there's a big question of how on earth do you do that when you're all working online? And I think there's a real worry there that actually, are all of these institutions going to move online and say, do you know what, this is too difficult, getting people to build prototypes, getting students to work together. It's much easier to do something like I'm doing now, to deliver a lecture or talk to students, and actually for these courses to become much more passive. So a lot of universities are really looking at how do we do this, because we don't know how long this pandemic is going to last, but actually a sense of, as student cohorts get larger and larger, we know maybe how to deliver project-based hands-on learning to 50 students or 100 students, but how do you deliver it effectively to 1,000 students? And how can you use technology to do that better, and to do that in a way that's personalized to each student? So this actually is what I'm working on now. So for the next year, the project that I'm looking at is, this question: how do you deliver engaging hands-on projects online or remotely, both to help universities think about how to design the best possible education now, but also to think about where we're going to come out of this, because so many institutions are saying, we've made changes very, very quickly. Some of them are working, some of them are really problematic, but there's not much we can do about it. But we're not going to go back to where we were before. There's been so much learning from this period. We want to actually apply some of that learning long term. So that's what I'm doing. I don't know whether this is going to come through, but this is what I'm doing at the moment. So I'm back at those lists of universities that I highlighted as current and emerging leaders. I'm going back to those institutions and saying, how are you delivering online collaborative learning? So this is kind of consulting group A. And then I'm going to looking more widely and asking the community, where do you think is doing a really good job at this? What can we learn from some of the other universities that are able to deliver genuinely collaborative project-based experiences where there's real student learning, but doing it remotely online, and pulling that together and actually collecting some case studies. So I'm at the moment, I'm focusing on case studies. This is an interesting time to be speaking to you because I'm just finishing off one case study on engineering challenges. So for Cattolica, that was the case study that we picked of, this is an institution that seemed to be an emerging leader in engineering education. Engineering Challenges is a big hands-on project with a hands-on course with a lot of moving parts to it. How did the university move that online, and what were the challenges and what were the successes of doing that? So what I'm doing at the moment is looking at a series of different case studies from different institutions. And a lot of them are highlighting some of the key issues that universities are facing. So I'm really early in this project, so I'm not I can't give you any kind of answers of what people are saying, but certainly when I'm talking to universities and asking them what are the real problems here, because that moving online and designing a course online is so difficult. If you want students to be an active part, if they sit and listen, it's more straightforward. But if you really want to engage students in a different way, the first is how do you evaluate it? How do you evaluate the development of students' skills and particularly their mindsets over a course? And one of the case studies I'm looking at is from Aalborg University in Denmark, who've done a lot of work, and they're developing an online tool to try and track, how are students developing their creativity over time, their ethical thinking, their design thinking, all of those things. It's very difficult to capture that when you're not sitting in front of students. A second one, and this is something that comes up repeatedly: how do you allow all students equal access to education, regardless of their home environment and their internet connectivity? Because a lot of universities are saying we're coming up with some really interesting high technology solutions to engage students. But it requires students to be engaging synchronously, i.e. at the same time as each other. What happens if they only have access to one laptop in their household? What happens if their internet goes down? What happens to those students compared to the students who don't have those challenges, or whose internet happens to have not gone down? That actually there's a real issue there of making sure all students have equal access, and you don't have a two-tier system depending on the kind of access that students have. A third question is about collaboration. How do you get students to, especially new students, if you're coming in on the first year, you've never met anyone physically, you're in a team, let's say, you don't know anybody, it's very intimidating. How do you build their relationships between the team? How do you allow students to network beyond their team? How do you get them to feel part of the institution? And one of the case studies I'm looking at is with MIT, actually, on that. And they've come up with a really lovely project. Someone was telling me, I think that it's something similar that happens on Reddit, but I don't know. But they have a kind of gold coin system where teams are allocated with these coins, and by helping other teams, it builds up their store of coins, which allows them to receive more help, but actually just a mechanism for building their connectivity and relationships beyond the team. And one thing they talk about a lot at MIT is this kind of what's called an imposter syndrome. You arrive at a university and you don't feel that you should be there. You don't feel worthy of being a student at that university. And a lot of that is about, making sure that the students do feel that they belong there and do feel that they're contributing to that institution. So there's another case study there. Another one is about supporting individualized and personal learning. When you've got 200, 300, 400 students, or in the case of engineering challenges, 830 students, on a Zoom call, how do you ensure that you are thinking about each individual student and their own development, because every student has a different learning style, a different areas that they feel more or less confident with, that they have different academic backgrounds. How do you support that in the online environment? And then the final one is about making authentic connections outside the university to solve real problems. When students can't physically get out, how do you do that? And one of the case studies that I've just finished actually is with SUTD in Singapore, and they had a project where they partnered with the regional hospital, acute care hospital, that was working with COVID patients, and they connected the students with mentors of clinicians from the hospital, and they had live kind of cameras within the hospital, obviously with permission from everyone involved, so the students could really see what was happening within the wards. And then because it was online, the mentors were able, you know, in their scrubs, kind of coming in at coffee break or lunch break, actually talking to the students and giving them advice about their projects and about the different solutions they were coming up with. And actually those kind of connections you would never do face to face. You just couldn't make that work. And actually, so for a lot of these projects, there are real challenges, and there are some challenges that it's very difficult to see how universities can overcome them at all. But actually, there are some really interesting advantages as well, and benefits of online learning, like making those kind of connections that a student just wouldn't have been able to walk into a COVID ward and have those kind of conversations with the clinicians that are treating people. So that's the other part of it, is trying to look at, you know, what are the advantages and how can we learn from that. So I was just going through each of those individually. But I'm for the project, I'm working on it all of this year. I'm launching just before Christmas a website with the first set of case studies, and I'm hopeful that Cattolica will be one of those case studies that will be finished and ready to go on the website. So if anyone's interested, I can send through the URL. But over the next 9 months, more case studies will be added to that, just giving some insight into how universities and faculty members can think of different ways of designing experiences that really engage students in collaborative and project-based experiences, even if they're on the other side of a screen rather than sitting in the same room. So thank you very much.
Thank you very much, and congratulations on your current research. We have learned a lot. It is very interesting. So now we will start with the round of questions. As I told you before, you can raise your hands and open your microphones to ask your questions in English, or you can send us your questions in the Zoom chat or YouTube stream in English or Spanish. So we're going to start. Is there anyone who wants to ask something?
I have a question.
Okay.
My question is about more multidisciplinary learning, because you said it is one of the pillars of the emerging leaders. And it seems to be the answer to complex problem, but how can we ensure multidisciplinary learning? Why is my question? I studied engineering physics, and I had physics teachers and electrical engineering teachers, but none of them was truly an engineering physics teacher. So they know about one discipline and other discipline. I studied about both disciplines, but is it truly multidisciplinary?
And I think what's really important is that you have both, that you don't have a whole cohort of students who know a little bit about everything, that actually having that core specialism, that you are, you know, you have that kind of physics core to your knowledge and to your experience. But it's the layer on top of that. So I think it's blending those both. You've got that absolute core that nobody else is bringing with them, but it's the ability to interact and I think an acknowledgement that for the vast majority of people, I guess probably unless you're in a very siloed research area, you know, but even then, you know, if you look at university research, it's so multidisciplinary. All of the new research centres that are opening up are multidisciplinary. And what's really essential to that is that as a, for me as a mechanical engineer, I'm able to understand the language of other disciplines within engineering and beyond engineering, and convey my ideas in a way that's really fruitful for that team. So I think that there's definitely two layers, and you'd never want to get rid of who each of you is fundamentally as a specialist in your own field, because that's what you're bringing to the team. But actually that ability to really hear and understand other disciplines, also, actually understanding. So I kind of get what chemical engineers bring here. And so that then when you're working in industry or wherever it is that you move on graduation, that you're really able to work effectively with others, and actually not just across disciplines, but across countries and cultures, that actually that kind of team working is so much fundamental. And I think also that flexibility that, so many people are not going to graduate with a single career anymore. I think it's something like 7 different, that this graduating generation will probably have 7 different roles or jobs, and actually your ability to weave between those and to understand what you're bringing uniquely, what your skills are, and working with others is just so important to that kind of career path.
Okay, perfect. There is another questions in the chat from Enrique that says, what role do you think character education plays in engineering education today?
Arts education. Was that, sorry?
Character education.
Character.
Yes, I believe character education, I don't know, Enrique is there. It's about like civic education, like in the role of the service in engineering.
Okay, I've never heard that phrase before. I mean, if it's what I understand it to be, as in the role that you as an individual play in sort of as a driver for positive world change, is that what? Yeah, I mean, to me that's absolutely crucial from many respects, but actually really understanding what kind of impact you have as an individual, and thinking about that decision-making process, and having an experience of making those decisions. And actually, I mean, to me, a really important part of an undergraduate education is failure. The understanding what it feels like to fail, and what it feels like to come out of that and to learn from that, and to not make similar mistakes again. And I think all of those things are so important, because you don't want to make those mistakes in whatever decisions you're making as a professional engineer. So I think really thinking not about abstract problems, but about real problems that impact the world around you are so important for so many respects, but that actually understanding all those different priorities, and that the decisions you make as an engineer are not going to be 100% technical. It's very rare that as a professional engineer that all of your decisions will be purely based on the numbers and whether or not it's going to crack or whatever it is. That actually there's so much more to that decision-making process, and understanding even what those different kind of constraints might be are really important. So to me, character and I mean, a mindset is just so important. Sort of say kind of ethics and creativity and problem solving, and understanding the people that whose problems that you're solving, it is absolutely crucial.
I agree. There is another question from Daniel that says, hi, have you seen solutions for the limited human interaction based on virtual reality technology? I understand that such high-tech solutions will probably be quite limited, but it seems only logical to use it during digital-only interactions.
There is. I mean, I was talking about SUTD, and actually they're investing hugely in AR, VR, digital twins, that but not actually as a remote learning tool, but as an on-campus learning tool. So if you want to create a prototype, creating a 3D prototype in VR that people can interact with and alter, and those sorts of developments, I think, are really exciting. The constraint is how and can you do that when students are working remotely. So I think that kind of educational technology is something that's really, it has huge potential. I think one of the issues at the moment is there's nothing, or there's very little commercially available that really gives engineering students what they need. And of the universities that I know, like SUTD, that are really investing in this, they're creating bespoke solutions. And that's not something that's available to all universities, and it's not a cheap enterprise. So there are some really interesting developments, and I think the potential is huge. But a lot of the solutions out there haven't really yet filled that need sufficiently well. And I think there's something about COVID. It happens obviously so quickly that universities had to roll out what was available, because very often there was a class the next day that needed to be delivered. And I think it's only now people are starting to think, okay, so but long term, what kind of solutions do we want to develop for the students in the long term? But I think as students start coming back to campus, maybe next year or whenever it's going to be, that the use of online learning and digital technologies, educational technologies, I think will have increased very significantly.
Thank you very much. Is there another question for Ruth?
Yeah, so I have a question about the programs that we study. So I think it's always been a challenge about doing practical projects or works in engineering. Personally, I have a major in design and innovation. So for me, it's normal to go and prototype and do that type of stuff. So it's really useful for me to learn by doing. But we also have all these courses that are you have to study by the book, and it's a challenge to do these projects in this type of courses in not online teaching, but when you go to the university. So what changes have you seen in programs of universities to do projects, like you said, work maybe in groups, now that we only have this tool that is our computer, and maybe we have distance and yeah, we can do 3D models or create solutions, but we can do have them in our hands and test them with the people. Mm-hmm. So have you seen new changes in other universities that maybe we can learn from?
I'm still looking. I mean, that's what I'm really interested in. A lot of universities have done different things. I talked to MIT, what have you done? And they've tried all sorts of different things. They've tried, we'll send out a kit of parts, get students to build a 3D printer. We'll just post it to them and see what they come up with. Asking students, build whatever you can out of whatever's in your house, and let's see what happens. Or saying, the hands-on part will all be based on 3D modeling. What I haven't found yet is a solution that is as good as or better than letting students into the Fab Lab or whatever it is that you've got on campus and giving them that hands-on experience. I mean, what some people are saying actually, though, is that spending more time on the modeling actually gives students more insights into, and actually allows a few more iterations and bit more thinking before they commit the time to building the thing, and then realize, that it's too heavy and it's never going to work or whatever it is. That actually the modeling, a greater focus on modeling is really useful. But I guess I think what a lot of universities are coming back to is saying, what do we need to be on campus? What are the absolute critical parts of the education that do not work as well online? And that a lot of that is, I think there's a part of the kind of team building and discussion and maybe some kind of user interaction, so the early part of the process, and then obviously there's the hands-on. And I wonder, it feels to me like what a lot of universities are doing is saying, okay, so let's take the rest of it out. All of that, the rest of the kind of interactions with students and parts of the curriculum where they don't need to be on campus. What can we do that's more innovative with that? You know, like the example from Charles Sturt University, having this topic tree, students accessing things independently and online. And so I wonder at the moment whether more creativity is going into that part, so that they can say, well, if our students are only going to be on campus 10% of what they used to be, let's really allow that 10% to be the hands-on bit. But I think that transformation of the rest of the curriculum has to be done with such care that it isn't just a series of recorded lectures, that actually that it's developed and delivered in a way that really responds to each individual student's learning style, and is supportive, you know, that it picks up on how they're learning and what they're not learning and actually provides additional support for that. But I mean, for the rest, it's watch this space a little bit. Hopefully I'll have a better answer in 9 months' time, hopefully.
Thank you.
There is another question in our YouTube stream that says, could a complete online education affect the performance of a computer engineering in the outcome?
Sorry, could you repeat that?
Could a complete online education affect the performance of a computer engineering in the outcome?
I'm afraid I still don't quite understand the question. Could how well they do in an online course affect the outcome of the degree? Is that how you mean?
I believe so. Jose, that is in the YouTube stream, is not in the Zoom, so he cannot give us feedback.
I mean, I think I don't know whether this is the right question I'm answering, but I think there is an issue where, you know, you've got things like Coursera or, you know, all of these different providers. And if students are accessing, and I think to a certain extent that's going to happen, you know, that there are certain courses. So I was looking just yesterday at some really lovely courses from Delft University in statics and various things, you know, that actually it makes sense to me if universities are sharing some of these resources rather than every university developing their own really nice online course where, you know, you've got a lot of support for students, that actually you access courses from different universities and you really find the best possible solution for each kind of subject. But the problem there is quality control, you know, that if you pass one course from one university, does it, you know, to what extent is that really going to count, and what do the marks mean in terms of, you know, at your own university? So I think there is an issue there about accessing materials from outside. But my sense is that there's a real sense of collaboration. So many universities and so many, you know, deans of engineering and heads of department that I've been speaking to have said, you know, and we all know who our competitor universities are, and we were always slightly wary, you know, because we're competing for students. But there's been something about COVID where all of those barriers are often completely thrown down, and actually people are working together and saying, look, you know, what can we do to help each other? Let's create common materials that we can both use, we can all use. So I'm thinking, there's a sense to me that there's a shared challenge here, and there are real opportunities for shared solutions, and that I find that incredibly exciting, because actually a lot of engineering courses are, you know, that the pieces in the recipe are very similar. You know, I did a degree in the UK. Students here did a degree in Chile. I bet you 90% of the courses that we studied are the same. A lot of the learning outcomes are the same. And other than the language barrier, there are, to me, there are very good reasons why every education is you know, bespoke, and but there are very good reasons why, for me, why the statics course that we sit shouldn't be the same. And you know, just as universities could be helping each other, students from different universities could be working together. And there's some really nice systems where, you know, there's a lot of interaction and, you know, and peer support. I don't understand this concept, you know, you submit it and other students help you with the solutions, and that doesn't have to be from the same university. So I don't know whether that's answering the question, but I'd say I think there's some brilliant opportunities there. But there is an issue about, you know, what does a course, if you took a course from Delft or from MIT or wherever, how does it count, and how do you take those marks and integrate them into a degree at your university?
Perfect. Jorge?
Thank you. Hi, Ruth. So thank you very much for being here.
Hi.
I was really intrigued by the experience you told us about MIT and the this coin. So just to put things into context, I teach computer science courses, and just, you know, the last question was suggesting, you know, this appears to be something you can teach online, and nothing like it's going to be fine. You know, even now I'm thinking that my students may be even learning more than they used to. But if you think about the what happens even in the normal setting, in which you may have 120 students in your class, you know that there are a few of them, so maybe more than a few, that are going to become really isolated somehow. They're not going to interact too much with other students, and I'm wondering now what happens, what is going on with that now that we're in the online setting. So I believe that some of my students interact between them, but I'm not sure that they actually are benefiting from these interactions. Yeah. And so I'm wondering, so if you perhaps you can give us a little bit more about what they're doing at MIT, yeah. And if you think that these tools may also be useful in a you know, not online setting, like when we're back, you know.
Yeah, I mean, I really agree. It's those students that I would worry about, you know, the students that don't turn the cameras on, that you don't know, you can't see them, you don't know how they're learning, how they're feeling, you know, that there are all sorts of issues there. And, you know, maybe they're in a team that they don't, for whatever reason, feel part of or good enough for, or whatever it is, or there's some tension in the team or whatever. And I think when you're face to face, you know, you can turn around and chat to the people next to you, you can be part of something, whereas online there's a real danger that those students just get lost and don't really know how to reach out. So that's why I was really interested in this case study. I'm still finding, I've only done a couple of interviews for that, but my understanding of what they do is that they're all solving challenges around Cambridge, which is the part of kind of Massachusetts where MIT is based, and it's around sustainable development goals. And they each choose a sustainable development goal and develop a project around that. And I think each group is given a number of gold coins that they can spend any way they wish with the other teams. Faculty and students, and these are all first year students, so they're all coming in fresh to MIT. So at the time, you know, they haven't been on campus for a lot of them because the campus hasn't opened properly. Other faculty and students are also given these kind of coins to spend, and they can use them in any way they want. So let's say they need to find out, I don't know, about sewage systems in whatever it is, you know, or the rough sleeping in the town, that actually they put out a call. And if you help another team and say, actually, I know somebody, or I can connect you with somebody, and it's building up those connections, and then the faculty and the students can also offer help. And you can vote on which projects, you know, as they present throughout the term or throughout the semester, you give coins, you know, think, oh, that's a really good idea, I like that. But there's always an advantage coming back to you to doing that. And there's also a system, and I don't quite know how it works within the team, but to support the kind of networking and positive interaction between the team. But a big part of the kind of the goals of it is to build both the positive feeling, because one of the things they talked about actually is the worry that it all becomes very competitive, and then, you know, we're not going to help you and we're not going to tell you what we're doing because it's going to benefit our project. And they wanted to kind of turn that on its head and actually know, if you work as a cohort, all of you together, you all benefit from that. And that actually building those connections outside that cohort to the, you know, to, even though they're not physically there, to, you know, to the region and to other faculty in the building, the other professors, the other students. So that's seems to be how it works, and it's all online. So, you know, you look on things and you see a request for something, and you can kind of, I mean, I remember playing Clash of Clans. In my head, it's a little bit like that. Somebody wants something and you you give it to them, and if you do, you get some kind of reward back. I think it's that kind of idea. But it sounds, I mean, and I've only had a few interviews, but it sounds from the student perspective that it gave them a reason to reach out, you know, that they wanted to make connections, but they didn't have a positive reason to. And it gives the students a real mechanism and a reason to make connections with other people. And then you build friendships and you build trust. And I mean, hopefully this case study will be online in the next couple of months. So I'll let you know when it comes out, but it sounded fabulous, because that exactly what you're talking about is what so many, I think so many professors really worry about, is, you know, that how many students are lost here in this system when we can't look out at the lecture theatre or look out in the Fab Lab or wherever we are. We can't see them. How are they, and how do we know that they're okay, and how do we create mechanisms if they don't want to be, you know, told, right, I'm going to have a one-to-one conversation with you because you seem to be failing, that actually a positive reason that they can make those connections that they want to.
Thank you.
Okay, given the time we have left, the last questions is from Paula, that says, have you studied the challenge of having voluntary presential classes, like some students online from home and some in the university on the same course at the same time? So
when students can choose to be on campus if they want, or they can be at home if they want. I've looked at some. I mean, I think the real difficulty is so many universities are preparing for every eventuality. You know, it could be 100% online, it could be half online and half not, it could be fully on campus. And I think one of the problems with the half online and half not is that you may as well have all of the students online, that in order to make sure that the students accessing it online are getting as good as an experience as the people in the lecture theatre or wherever in the classroom, it's the experience is pretty much through the computer screen anyway. And I think one of the issues is the students will sit in the classroom with their laptops on, and the experience really isn't that different, other than the fact that maybe they haven't got some of the, you know, the home comforts and facilities they have at home. So I think the people I've spoken to have found that quite difficult to make work, that they're so conscious of the students online and wanting to make sure that they're not getting a worse experience, that the students who are actually sitting in front of them may as well be online. So I don't have a lot of examples, and I think so many universities, it's emergency mode. You know, they're doing, rules are changing every week. You know, then when you're told, oh, you know, you might be able to come into campus next month. Oh no, you're not going to be in campus. And I think because people can't plan, a lot of those mixed mode, you know, online and in person, end up effectively being an online experience anyway.
Perfect. Thank you very much, Ruth, for your time and great work in the educational field. Without a doubt, this pandemic has changed the learning process for students and for our teachers alike. And it is in our hands to keep searching for ways to improve this process. Also, I would like to remind you that this week is the online teaching week, where there are different activities that you can attend for the rest of the week. Thank you again, Dr. Ruth, for your time and for sharing your experience and investigation with us.
Thank you.
Thank you very much.
Thank
So,
you.
Bye, thank you.
bye-bye.
Thank you.
Thank you.
Bye-bye.
Bye.
Felipe, no sé si estás ahí. O Josefa, alguno de los dos.
Sí, acá.
Ya, acabo de ver el mensaje de Felipe que decía que la están trabajando para una investigación, creo que la pregunta que no alcanzamos a hacer. Déjame ver si podemos ver de que ustedes le escriban un mail a ella, porque ella en verdad responde súper rápido y todo.
Ya, acá.
¿Me podéis dejar tu mail y por última te mando en copia a un mail de ella?
Sí, sí, obvio. Te lo mando al tiro. Te pasaste.
Gracias.
Buenísimo, sorry, estábamos muy justo de tiempo.
Sí, no, tranqui. Se cachó. Como que hubieron hartas preguntas, estuvo bueno.